Hello, you're on Pablo Spot. I'm George. Welcome to a new episode on this series on setting up load balancer infrastructure, and today I will be exploring the cost management aspect that involves load balancers. And so if this series and the content of this channel lines up with your interests, hit the subscribe button and join me in this journey of learning by doing. So, let's start coding. On the previous episode, I integrated ECS with Load Balancer to allow two of my containerized web applications to be accessible to the internet. I have used two Terraform modules that I've written in the past for this implementation. This setup is fine, but this is one of many traps that most people fall to when setting up infrastructure code. And so what is this trap? This is creating resources that result to unnecessary cost. And in this case, I am creating two load balancers when we can in fact just have one. And to give you a little bit more of insights on what I'm talking about, let me switch to my terminal and then export TF workspace. And then set my AWS credentials using AWS Vault. And what I'm going to do next is run infracost to generate a cost breakdown on the infrastructure that's part of my code. This output shows me the estimated monthly cost that I will incur for all the infrastructure resources created inside my code. And if I scroll a little bit up this output, notice that there's cost involved in each of the load balancer resources that I have set up. When we follow this setup and add more web applications in this infrastructure down the line, we will end up incurring costs for each web application that we set up because of the load balancer that's created for each web application. So how do we address this? The first thing that we need to do is refactor my ECS Terraform module such that the target group resources is created inside the module itself. So let me head to that repository for my ECS Terraform module. So this is my Terraform module for my ECS resources. So what I'm going to do is head to my main.tf. And I will add a new resource block for target group all the way to the end of this file. I am going to set the basic property for this resource called name and set this to the value of my service name plus the Terraform workspace. I'm going to add the port property and set the value to the main container port local parameter. And then I will set the protocol property to HTTP. And add another property called VPC ID. To assign the value for this property, I will use the VPC ID variable if it's defined. Otherwise, I will use the default VPC ID. I will add another property called target type and set the value to IP. And then I will add a health check block to verify that the web application on my ECS are ready to accept requests. This health check block will check the health of my web application every 10 seconds, which is indicated by the interval property. And then a check is considered healthy if the response code is either 200 or any value between 301 and 399, which is what the matcher property is for. If at any point the health check fails in 6 consecutive checks, the web application will be considered unhealthy, which is indicated by the unhealthy threshold property inside the health check block. I also need to add the target group ARN as an output of my ECS Terraform module. And so I'm going to open my outputs.tf. And add a new output variable. And set the value to point to the ARN of my new target group resource. And then lastly, on my variables.tf, because I am now setting the target group resource inside this module, I can then get rid of the target group ARN input variable. And now let me head to my VS Code terminal and then commit and push my changes. And then I'm going to create a new version tag that will contain my recent changes. And then push my new tag. And now let me switch to my browser and then head to GitHub repository for my ECS Terraform module. And then in here, I'm going to head to releases. And then onto tags. And then I'm going to click the new tag that I've created. And then all the way to the right, click Create Release from Tag. And then once the title and details field are provided, scroll down and click Publish Release. And now that I have a new version of my Terraform module available for use, let me head to my Terraform Cloud account. Select Pablo Spot. Go to Registry. Select Modules. And then open Pablo Spot ECS private module. And what you will notice here is the new version that's available for use is the version 0.12.0, which is what I just created. Now let me switch back to my code. The next module that I need to refactor is my load balancer Terraform module. So let's head to that repository. So this is my repository for my Terraform module for load balancer. So what I'm going to do is head to my main.tf. And then I am going to get rid of the target group resource that's created inside this file. And then on my variables.tf, I will also get rid of the application port input variable since this is no longer required. I also need to update my output variables to add my load balancer listener ARN. And so let me head to my outputs.tf and add a new output variable. And then I will set the value to point to the ARN of my load balancer listener resource. I also need to update how I create the Route 53 record resources that will expose access to my load balancer to the internet. So let me head back to my main.tf. And head to that part where my Route 53 record resource is created. Because I could end up having different endpoints that expose my load balancer, I need to add a for each property inside this resource block. And then I'm going to set the source for this property to a variable. And because I'm using a new variable in here, I'm going to head to my variables.tf to set that definition. Now back to my main.tf. This new variable is a list, so I need to convert this into a set that can be parsed through the for each property. And then, instead of using the system name input variable, I will set the name property to use the key derived from the for each property. And now, let me head to my VS Code terminal and commit and push my changes. And then I'm going to create a new version tag that will contain my recent changes. And then I'm going to push this new tag. And now let me switch to my browser and then head to the GitHub repository for my load balancer Terraform module. And then on this page, I'm going to head to releases, go to tags, and select the new tag that I've created. And on the right, click Create Release from Tag. And then populate the title and the description of the page. And then scroll at the bottom of this page and click Publish Release. And now that I have a new version for my Terraform module, let me head to my Terraform Cloud, go back to Registry, Modules, and then open the private module for my load balancer, which is right here. And notice that the new version is now pointing to 0.0.3, which is the version of my previous change. And now that both my load balancer and ECS Terraform modules are updated, let me head back to the repository that I have set up from the previous episode. So the first thing that I need to do is head to my main.tf and update the version of the Terraform modules that I am referencing to use the version that contains my refactoring changes. So let's start with ECS. I'll update this to point to version 0.12.0. And then all the way to my load balancer Terraform module, change this to version 0.0.3. And on this load balancer Terraform module, I only intend to create one load balancer, and so I need to get rid of the for each property. I also need to get rid of the application port property since that's no longer required. And then I'm going to change the value of the system name property and set it to generic. And I've introduced a new input variable to my load balancer Terraform module called endpoints. And the value that I will assign for this property will come from fetching each key from my applist local parameter. So it will look like this. What the code on line 32 does is it extracts the keys defined in the applist local parameter. I need to link my load balancer with the two ECS applications that I have set up. And to do this, I will head to the end of this file and create a new load balancer listener rule resource. I will set a for each property inside this resource and use my applist local parameter as the source. And then I need to add a listener ARN property and point this to the listener ARN from my load balancer Terraform module. I also need to add a condition block inside this resource. And evaluate the host header of the request. I will evaluate this based off the key fetched from each element of the for each property appended with my domain. So this is essentially evaluating each of the website endpoints that I have set to make my load balancer accessible. I don't want to have the domain hard-coded this way. So what I will do is head to my locals.tf and define a new parameter called base domain. And set the value to pablospot.ml. And then back to my main.tf, I will replace all instances of pablospot.ml to a reference to the new local parameter that I've just set. And then last but not the least, I need to define an action block inside my role. I will set the type property to forward. And then set the target group ARN accordingly based off the output of my ECS module. And then head back to my Terraform module for ECS. And then get rid of the target group ARN input variable that's passed to the module, which is at line 22. Now, let me head to my VS Code terminal and then export my TF workspace environment variable. I already have my AWS credentials set on this session, so let me go ahead and run Terraform init. And then Terraform plan. Let me go ahead and rerun my infracost. Notice a drop on the total monthly cost that I will incur for my overall infrastructure resources. And if I scroll a little bit up this console, notice that I only have one set of load balancer resource as part of my infrastructure code, which means the cost related to my load balancer has gone down 50%. This is because I have cut down my load balancer from being 2 load balancers, one for each web application, down to just 1. Technically, we do not have to spin up multiple load balancers. With the limits and quota accounted for, you should be able to use just one load balancer to proxy web requests to multiple web applications in ECS or through any other services in AWS, or even redirecting requests to other web services outside of your space. So make sure you don't fall in that trap. Otherwise, you will end up incurring more costs that you may not realize down the line. And that's all I have for infrastructure resources for load balancers. Let me know your thoughts in the comments below and send me some likes if you find this useful. And don't forget to hit the subscribe button if you like the content on this channel. Until next time, keep learning and stay safe. See ya.